Hey, welcome guys to the Crack the Placements channel. So today we are going to study the iterative way of post order traversal. So first thing, let us understand the concept behind this post order iterative traversal. So I have already said in the previous videos that if you want to perform the iterative traversal in any kind of traversal, whether it is a pre-order or a post order or a in order traversal, so if you want to do it in iterative manner, then we must and should have one stack with us. Okay, now let us see how to do this traversal. I am going to consider a simple tree in order to explain the things. Okay, so let the tree be 1 2 and this 2 has the left child as 3 and right child as 4 and here 5 is present. First, the root node will be pointing on this 1, so I am going to use a stack as I have already mentioned. So when the current node is on 1 and if the currents left, that means if the current node has a left child, that is 2, in this case 1 has a left child 2, in this particular case we must have the reference to this object 1 so that we can backtrack to this 1 later on. So hence I am going to push this 1 onto the stack and then I will traverse to the left of this 1. Okay, now the current is present upon 2. Now I am going to check whether this 2 has a left child or not. Okay, do the 2 has a left child? Yes, 2 has a left child and that left child is 3. So I can traverse from 2 to 3, and before that I have to push this particular 2 onto the stack so that I can have the reference of this 2 and I can back traverse to this 2 later on. So hence I am going to push this 2 into the stack and then I will traverse from 2 to 3. Now the current node is present on 3. Okay, and again this current is not null, so I am going to push this particular 3 onto the stack, and after pushing it onto the stack the current is going to become null. So because no element is present here, so hence the current will be null. Okay, as the current is null in this case, what I can do, if the current is null, then I am going to take the reference of this element in the current node. That means the current is going to point on this 3 and I will check whether this particular 3, that is the element which the current node has pointed, has the right child or not. Suppose if this 3 has a right child, then we will traverse to that particular node, but in this case the right child is not present, so we will print the 3 and then we will pop this element out of the stack. So hence 3 has been popped out from the stack in this case. So 3 is popped out. So before removing the 3, that means we have popped the 3 out of the stack, and we will keep a reference pointer called as last, and in order to keep the reference which last node we have already been visited. So now we will make this pointer to point on this 3 and we will make the root as null. That means root is pointing nowhere. So what this last pointer is suggesting us, this is suggesting us that we have already traversed this 3. Then okay, so as the root is null again, we will take the reference of the node 2. That means the current pointer which is present, it is pointing on 2 at the particular instant. And we will check whether this 2 has a right child or not. In this case 4 is the right child of 2. Okay, so what we will do, we will just traverse from 2 to 3. Now the current node will be on, okay, now the current pointer will be on 4. So hence we will push this 4 onto the stack. Okay, then now the current is present on 4. We will check whether this 4 has a left child or not. So okay, as the current node is pointing on 4 and the current node is not null, okay, so we will traverse this current to the left and the current becomes null. As the current is null, so first we will take the reference of the we will store the reference of the top of the element into the current. So hence the current is going to become 4. So from here the current is going to point on 4, and we will check whether this 4 has the right child or not. Okay, in this case the 4 doesn't have any right child, so we will pop this 4 out of the stack and then we will print that 4. And as I have already said, so before leaving this particular node 4, so we will update the last pointer and we will make the last pointer to point on 4, and then so we will, okay, so make this current as null. So here current and root are equivalent, so I just flipped the names okay in between. Okay, so now the last pointer is pointing on okay 4, and okay, so C has become null. Now as the current node, that is C, or the current pointer C or the root pointer is null in this case, we will take the reference of top of the node. So this has been pointed, that okay, this has been popped out, that is 4 has popped out from the, okay, 4 has been popped out from the stack. So now we will take the reference of the top of the stack, that is 2. Now the current is pointing on 2 here. So we will check whether the root's right has been traversed. So okay, so in this case this last is going to help us. So if current's right is equivalent to last, then in that particular case we, okay, so if the current's right is equivalent to last, it suggests us that we have already traversed this particular node, that means the node which is being pointed by the last. So we need not again move from 2 to 4. In order to do that, so we have maintained the last pointer and then we have reference to 2 now. So what we will do, so we will okay add this particular 2 element to our okay post order list, and then we will pop this 2 out of the stack. And again, so if the element is popped out of the stack, so what should we do? So we should what we should do, we should update the last pointer. That means our last visited node is 2 and we have made our current to be null again. And after that, so as the current is null, so we will take the reference of the top of the element in our current. So our current is pointing on 1 now, so we will check whether 1 has the right child. In this case 1 is having the right child, that is 5. So we will traverse from 1 to 5, and then we will, okay, so push that particular 5 onto the stack. So our current is present here at the present moment. So we will check whether this 5 has the left child or not. That means, okay, so before checking, so we will make this current, okay, to traverse to the left of the, okay, left of the node 5. So current becomes null. So as the current is null, we will take the reference of top of the stack, that is 5, and the current is again pointing on this 5. Then we will check whether, okay, so this node 5 has the reference, okay, that means has the right child or not. If the node, that means the node which is pointed by the C, that is the current pointer, doesn't have the right child, in that particular case we have to pop the element out of the stack, and then we have to add that element to our post order traversal list, and we have to update the last pointer. Now the last pointer will be pointing on the 5, and the root is going to be, or the current pointer will be made as null once again. So we have popped this, okay, so 5 out of the stack, and the only element remaining in the stack is 1. Now as the current is null, we will take the reference of the top of the stack, and now the current is pointing on 1. Okay, so and we will check whether this current has the right child. Yes, it has the right child, but this, okay, right child has been visited previously because the last pointer is pointing on this 5. Hence we will pop the element 1 out of the stack, and then we will append it to the list and make the current as null, and the last will be pointing on the root node. Now the stack, okay, so I have popped out 1. So now the stack has become empty, hence I am going to terminate the loop, and our post order traversal is complete. Now let us code for this iterative post order traversal. So first we require a vector. So let the name of the vector be post order, and also we require a stack, that is tree node S. So this stack is going to hold the reference of the nodes which we have visited, and it is going to help us in order to backtrack the tree. Okay. So we will continue this loop until the root is not equal to null, or the stack dot empty, that means the stack which is present, it is not empty. So this s dot empty is going to find whether the stack is empty or not. If the stack dot empty, that is s dot empty, is equivalent to false, in that case it is saying us that some of the elements are present in the stack and the stack is still not empty, so you can perform your operation. So I am using the OR operator because initially the stack is going to be empty. In that case we have used the condition root is not equal to null, so that inside the while loop we can push the root element inside the stack, and the stack is automatically going to be non-empty. So first case I am going to check whether the root is not null. So if the root is not null, then what I will do, first I must so push this root onto the stack, and then I must travel to the left of the tree. So root is equal to roots left. Okay, I have already suggested what I have done, so it is cleared now. And after that, if the root is empty, so if the root is null, in this particular case, first if the root becomes null, I must take the reference of the top of the stack into this root node. So that means root is going to hold the reference of the top of the stack. In the indirect way, root is going to point on the element which is present at the top of the stack, and we will check after taking the reference. I am going to check whether roots right is equivalent to is not equal to null, or Okay, if the roots right is equivalent to null, or roots right which is present, it is equivalent to last. So I have to create a last pointer here. So initially the last pointer will be pointing to null, and if we take the reference of the element, that is reference of the top of the stack into the root, and we will check whether roots right is present or not. If the roots right is not present in that particular case, or the roots right element is pointing on the last traverse node, then in that particular case there is no need that we have to move to the roots right. So what we will do, we will push this particular roots value into the stack, and then we will pop that element out of the stack. And after popping that element out of the stack, what we have to do, we have to set the last pointer to the previously visited element and make the root as null. Else, that means if the roots right is present, we have to traverse to the right of the subtree, and then okay, so pointer is updated here. If the root is not null, it is going to be pushed. I think I have completed the code, and I'll return the post order vector. Let us see if it runs or not. Yeah, it's working fine. So I'll submit the code. So the solution is accepted, and I have explained the post order traversal, that is the iterative post order traversal, in a very detailed manner. So please don't forget to subscribe, guys. Thanks a lot.